Hello everyone. Now let's take a question from binary search. So we can take this question. Search in rotated sorted array. Okay. Search in rotated sorted array. Okay. There's an integer array nums sorted in ascending order with distinct values. Okay, the nums is already sorted. We don't have to sort it. Prior to being passed to your function, nums is rotated at an unknown pivot index. Okay, so if this is array 1, 2, 3, 4, 9 and 11. So from here it is rotated. This is indexes k such that the resulting array is nums k and nums k plus 1. Okay, so the resulting array will become 4, 9, 11, 1, 2, 3. Cool. Okay, it is zero index. For example, this will be rotated to this. Okay, example is also given. Given the array nums after the rotation and an integer target, return the index of the target if it is in nums or -1. Okay, so after rotation, I have to find the array index. So yeah, we can do it in order of n. That is pretty straightforward. But we have to do it in order of log n. Okay, how to do it in order of log n? Uh, yeah, you must write an algorithm. Here it is also written. So let's see what we can do. Okay, k is already given. Oh, k is not given. We have to also check for k. Only input and target is given, such that here k is equal to 0, 1, 2, 3 and 4. K is 4 in here. Okay, okay, okay. So what I'm thinking of is, let's go in the middle. Okay, let's go in the middle. Let's take this example. It would be better. Or let's get our own example. Okay, 4, 9, 11, 1, 2, 3. Let's suppose we are now searching for 9. We went into the middle. Okay, I already rotated from middle, so it would be easy now. Uh, let's change it a bit. So yeah, let's add more numbers in here. Let's add like 3.5, 3.8, something like this. Okay, now our current middle is this, and this is our current middle, 4 and 4 numbers. Okay, no, not this. Mid by 2 will be this. So if this is our middle, I will go to it. We'll try to find whether right element is greater or smaller. If it is greater, and what we want is greater than the value we needed. Okay. No. Instead of checking it, we can also start from here. We will check the first element. Okay. If we found that the first element is greater than, if first element is greater than what we needed, then our answer will surely arrive in the right path. Okay, if it is greater, then this won't work. But if it is smaller than what we want, okay, so like if we want 9 and 4 is less than 9, so our answer will lie in this part. Then we have to somehow find this index and then binary search on this. Okay, so now let's do it. Let's try to implement into code. So if, okay, so what's the length of nums array? It could be 1. So if it's not empty anywhere, so if nums of 0 is greater than, or okay, is greater than or equal to target, target, okay, then there will be another case, else else we are like, if this is the case, we are gonna find our answer in here, like if it is greater than this. Okay, no, if nums of 0 greater than this, the answer will lie here, else in here. Okay, we divided our array into two parts. One, this part is already sorted, this is sorted, and this is the breaking point, like the k. Okay, we need to find this k and then do binary search here. This k will be also find through binary search. Okay, let's see. Okay, if nums of 0 is greater than equal to target, so let's do binary search in here. Left and right will be 0 comma length of nums while L is less than equal to R, mid equals L plus R upon 2, K upon 2. So what if, yeah, it will work. And 0 and what if nums of length is 0, yeah, it will work. What if it already is at the length of nums, like L is also on length of nums? No, while is less, L is less than R, we should put it like this. While L is less than R, mid is equal to L plus R 2. If nums of mid is greater than, if nums of mid is greater than, what's our target? Okay, let's write pseudocode first. It's a bit problematic to think like that. Let's do it. Yeah. So if nums of mid is greater than target, let's see. 4, 5, 6, 7, 0, 1, and 2. And target is 4. We have to search in here. If we somehow get reach here somehow, if it is k, so we have to distinguish between these two. Let's find k first. Okay, we have to find an index where this is less than this. Let's find k first. It will make our task a lot easier. Instead of this, okay, so how to write? Define find k. Define find k. We are going to give it nums, okay, and k value. If nums of k, not k value, instead we can give it L, R, and L and R. So if k, L is equal to 0 initially, R is equal to length of nums. So I actually haven't written code for binary search for long, so I have to check the condition also. So if nums of L, okay, while L is less than R, yeah, not while L is less than R, if L is less than R, or L is greater than R, then return. If L is greater than R, then break, okay, or return. So what if k is equal to 0? Okay, k could be 0. find the k this way. To find the k, what I can do, I can go to the middle, check whether this is less than equal to this or not. If it is following the rule, how to do it in order of log n? Four, five, six. Okay, instead of taking this example, I'm gonna take mine. 10, 11, 12, 13, 14, and 1, 2, and 3. Okay, so this could be one case. 4 and 4. So middle will be this element. We can see this is in sync. We can check for current max. Okay, so here we found that our current max is 13, but our answer could lie in left or right too, and this is 10. Okay, we have to find an element which is less than 10. That's all we have to do. The leftmost element which is less than 10, less than nums of 0. If we would be able to find it, then it would then okay, then after that we could do a left or right binary search in left and right. So how to find an element just less than 10, the leftmost element less than 10. So if nums of I, nums of mid is greater than nums of 0, then move forward or move backward. Okay, till one. Okay. We were gonna do this. So if L is greater than R, okay, if yeah, return -1. It means that the array is not rotated. Okay, if we have if we won't be able to find any index such that the value at that index, okay, second, the value at that index is get less than first element, then there must be like 1 2 3 4 5. The array is like this, sorted array. No element is less than 1. Okay, you can do this. So if L is greater than R, then return -1. Okay, else let's take mid. First, mid is equal to L plus R. We need to dry run it to check its validity. So if not, if nums of mid is greater than all are distinct values, so we don't have to be. If nums of mid is greater than nums of 0, then find k in rightmost part, such that mid is already greater than 0 na, so mid plus 1. Okay, no, instead of mid plus 1 I should, okay, let's go for mid plus 1. Mid plus 1 comma, if L is equal to R, L is okay, we are find mid plus 1 to right. Okay, else find k mid left and mid, yeah, left and mid -1. Yeah, this should work. Okay, if nums of mid is greater than, that's cool. Else if it is smaller than, then to mid only. Okay. and if L is equal to R, like you have to return find k, return find k, return find k, and if L is equal to R, or any other cases, no, if L is equal to R, what if L is equal to not R, like L is equal to R plus 1, R minus 1, so mid plus 1 will be called k, and here, but here mid minus 1 is not called, so it will keep repeating at any place. I don't think so, because 0 1 will become make mid is equal to 0 again. So if L is equal to R, and one more, and nums of L, okay, is less than nums of 0, then return L. Okay, let's see whether it is working or not. So print find k. Let's see. Oh, this is vague. We can't do like this here. If we will be able to find k, then everything will be pretty simple. So what I am printing, find k. Yeah, 0 1 2 3 and 4. Yeah, it's working fine on it. Let's run it on another test case. Okay, no, let's go further. It's already too much time I have taken. 17 minutes. This is a simple binary search question, still taking 17 minutes. Okay, but if you would be able to go slow, if you are going slow, then you understand this concept, you would be able to solve many questions on this basis. So now all we have to do is it's a simple binary search. Okay, so let's control that. If nums of 0 is greater than target, okay, then binary search on 0 to k. Yeah, you have to return index. Yeah, index. So return yes, return. I'm gonna create a new function, binary search, and gonna search for target. Yeah, target. Good. Else return and I'm gonna pass array to, and if nums of 0 is greater than, already greater than target, then to find, okay, nums of 0 is greater than target. Okay, yeah, so if the current nums of 0 is, see, if nums of 0 is greater than target, so we are going to find our answer in here, and this is k, 0 1 2 3 4, so we have to find answer from k to n. Okay, so nums of, if nums of mid is greater than nums of 0, find k from mid, okay, no, sorry, find k in nums, comma, not like this, find the target in k to n. This will work. Else find the target in starting to k. Should we add k? Yeah, we can add k, no problem. But what if k is at end? Oh, that's also a problem. So we have to check. What we have to check? If k is equal to this, if k is equal to -1, since that it's not in there, then simply binary search on the whole array. Okay. Else we are going to go on other options. Return binary search on nums array given target. Else binary search on starting to kth. Okay, and the given is target. Now we are gonna write our binary search function. Define binary search. You can create function inside a function too. So I'm creating it like this. So given array and given a target value, we have to do binary search. We are going to do same thing as above. So if L is less than R or greater than R, then return -1 as always. Okay, if L is equal to R and array of L is equal to uh, target, okay, then return L. Else we have to do this. Okay, so mid will be L plus R upon 2. Nums of mid is greater than target. If nums of mid is greater than target, then go to left, not right. So we have to do like less than. Yeah. Left. Okay. Instead of doing this, we have to do nums of mid. If nums of mid equals target, then return mid. Okay. Now let's try to run our code. L is not defined. Ah, yeah. I haven't put L in here. So our L will be 0 and R will be length of the array we are passing. Okay, let's see. Length of array we are passing. Okay. L comma R. L comma R. Target comma L. L is K and R is length of nums. We don't have to complicate these things, but still, it's okay. No big deal. Length of nums minus k. Minus k or not. 0. If you are starting from 0, yeah, this is okay. And in here, it is simple. It here 0 comma k. So yeah, it will work. Yeah, output is -1. Why? Let's print k first. And here we are gonna debug it through binary search. Okay, find k. Sorry. I haven't changed the function name. Okay, output is still -1. Expected is 4. Target is 0, so it is at 4th index. Let's print k. It was able to find k pretty good. So nums of 0 is greater than target, 4 is greater than 0. Okay, then try to find it after k. Yeah, and k is 4. So it should be able to find it. 3, 3, 7 is num, 7 minus k 7 minus 4 is 3. So yeah. But instead of doing this, I'm gonna do something else. Okay, so remove it. We are putting L and R now. So k to num, length of nums, and 0 to k. Okay, and in here target is also good, no problem. That is provided. I'm gonna print L and R here now. I always have some problem in writing recursive tree recursive question because return binary search of L comma mid. Oh, so array comma target comma L comma mid. It wasn't throwing error before. But yeah, I missed it. Okay, it's accepted now. Yeah, I'm writing it very lame. Like you can go for a better solution. L and R is also printed. Let's check on another test case. Okay, this one is checked. Okay, 1 and 0. Let's try it on here. Okay, instead of 3 and minus 1, 3. Target is 3. Let's go for target 3. And then we will check it on a list index. So index is out of range. Let's print mid to okay. 5, 6 and 7. Okay, 5, 6 and 7. Initially print L comma R comma mid. Four, 7 and 5. Let's see. 3, 3. Okay, it will reach till 7 if we are gonna pass R. So every time, okay, this R should be index then. If L is equal to R, what if L will become R? That's the problem now. So mid plus 1, that's because I'm asking them for mid plus 1 in here. So if nums of mid is less than target, I can go for this also. If nums of mid is okay, maximum depth recursion, cool. We have to change it. There's no other way. This is mid. So mid to R and L to mid. So if it is less than target, we have to change this to R minus 1 or something. If L is greater than equal to R. Okay. Then minus 1. We have to deal with that case if L is equal to R. Okay. So nums of mid, what I can do, how can I convert it? If nums of mid is less than target, this is right. Mm, let's put the index inside. That's the problem is in there. I'm not using index. So k is index itself, but I have to use k minus 1. Okay. And yeah, yeah, it will work now. R is I passed it as an index. Should we do it the same in the above case? Yeah, mid plus 1 we are also using in here. So let's do the same in the above case also. Now let's run it. It is target again maximum depth recursion. Okay, 5, 6 and 5. Okay, this is not called, okay, this is also a problem. Target comma 0 comma length of nums. This one I'm overcomplicating things, but let's go with the flow till now for now. Okay. 5, 6 and 5. So we are gonna put one more thing here. If L is equal to R and nums of L is equal to target, return L, else return minus 1. Let's do this one. Yeah, it's working. Let's again check it on other test cases like for 2 and for 4, and then we are gonna check it for 1. Okay, it is turning minus 1. So let's print k. K should be fine here at least. Yeah, k is 4. And when we go to the right, the nums of 0 is greater than equal to target. Oh, okay. This is the case. Nums of 0 is greater than equal to target. Yeah, so we are gonna go the k comma length of nums minus 1. Now mid will become here. Okay, that's the problem also. So instead of k minus 1, I'm gonna put k. Yeah, k will work fine. And what? Here we can also change it with plus 1. Okay, okay, let's try it. Mid to R and L to mid. So I stopped for some minute, and the problem was because here for our input, 1 second, sorry, something got done. So everything is fine. Like here, it is returning our solution. Okay, let's see. Yeah, for every options, it will return our solution except some. Okay, 1 second. Yeah, except options like this. So 0, comma 1, comma 1. So in this kind of test case, what you will find is, yeah, so this is wrong answer. So I wasn't able to find it by myself for some minutes. So I went for discussion section to see what's happening, and I found that okay, like I know what the problem is, but I wasn't able to solve it in order of login. Okay, so the case is if the first element and the last element and the sum of the elements are same, then you won't be able to find uh okay, and like these are same and this is pivot. Now we have to find the target one. Where will we find this side or this side? We don't know, we don't have any clue. But if let's suppose this is 2, okay, and this is 1 1 1 something like this, or this is 2, then 1 can't be between 2 and 0. Okay, here we can't put 1, so all ones will be at right side. So, the summary is if leftmost element and rightmost element are equal, okay, if both are equal, then we have to search the whole array, okay, in order of n worst case time. So I was able to find it, but I wasn't sure, so I went to the discussion. You can also do it sometimes when you are not able to find the solution. So our solution is correct for every case, but for this case, when the num0 and nums of -1 is equal to are same, then in that case we have to do it in order of n complexity. So let's complete. At first we have to do if length of nums is okay. If length of if num0 nums of 0 is same as nums of -1, then nums of -1, then return target in nums. Okay. Else every time it will be fine. Okay, let's try this now. Yeah, it worked. Let's submit it and see whether it is giving some problem on any test case one. Okay, wrong for the length of 2. So here we have to find 3. Okay. What is the pivot? Let's print pivot. Pivot is 1. Okay, we can't have pivot as 1. Let's suppose not like this. If pivot is equal to -1, or pivot or k is equal to length of nums. 1 second. Okay, so we are going to start from 0 to length of nums. It will make it better. Okay, yeah, now do this. It is running on it. Let's try this input. It's accepted in here too. Let's submit it again. Yeah, it got submitted. So and like to practice questions, sometimes the questions will be trickier. Like you won't be able to find some analysis. You have to do some analysis for the worst case complexity, or sometimes the corner cases. This was same here, that's why it took more like 5 more minutes extra to figure it out, and after I have also have to take help of discussion. Okay, so okay, thank you guys. Meet you in the next session. Subscribe for more questions. Thanks.